This video is on multiplying and dividing rational expressions. Since rational expressions are basically fractions, the rules that apply for multiplying and dividing fractions also apply to multiplying and dividing rational expressions. To multiply rational expressions, we're going to multiply the numerators and then multiply the denominators. To divide rational expressions, we want to multiply the first rational expression by the reciprocal of the second one. Then we can simplify by dividing out any common factors. Let's take a look at several examples here. First one involves only monomials. And I have 12c to the third divided by 21b times 14b squared over 6c. So I don't really want to multiply 12 and 14 and 21 and 6. That's going to give me really huge numbers. So I can actually go ahead and just simplify kind of within the numbers here. So I see a 12 and a 6, and I know that's going to that will simplify to a 2 over 1. 14 and 21 are both divisible by 7, so I can do a 2 and do a 3. And now just looking at my coefficients on top, I have a 2 and a 2 times 2 and a 3, and nothing else is cancelable there. Let's look at our b's. I basically have a b squared over a b, so that will leave me with the 1b on top. C to the third on the top and a c on the bottom, and that will leave me with a c squared on the top. So what do I have on the top of my fraction? I have 2 times 2, which is 4, and then I have a c, I actually have a b c squared over 3. Now if that was a little confusing, here's another way you could do it, because I sometimes tend to get lost in all of the little numbers. I'm going to do a prime factorization of my coefficients, and then I have a c to the third, and then I have a 2 and a 7 and a b to the second. Kind of write everything out here. And then 21 is 3 times 7, and then I have a b, and 6 is 2 times 3, and then I have a c. Now it looks a little bit easier to cancel out some common factors. So the first thing that jumps out is I have a 7's, and I have a 3 on the top and a 3 on the bottom. I have 1, 2 on the bottom, so I can get rid of 1, 2 on the top. And then this b is going to cancel with 1b there. This c is going to cancel with 1c there. And it's a little bit easier to see what's left. So 2 times 2 is 4. And then I have a b and a c squared over just a 3 on the bottom. So either way is possible. If you tend to get lost in some of the little numbers, maybe you want to try it the second way. Let's take a look at our second example here. A plus 4 over a squared times a over a squared plus 2a minus 8. So let's go ahead and factor anything that we can. And that would be the second denominator, which is going to factor into an a plus 4 and an a minus 2. Okay, now I can cancel out any common factors. So I have an a plus 4 on the top and bottom. And I have this a will cancel with one of these a's, and I'm left with, it looks like I have nothing left on top, but I actually have a 1 left on top, and then a times a minus 2. And you can leave it in factored form like that, or distribute the a if you'd like. Here are a couple division problems. I have 2x plus 6 over x squared divided by x plus 3. So I'm going to write that as, I'm going to go ahead and factor this. Okay, so there's my first rational expression, and I'm basically dividing by x plus 3 over 1, so I want to multiply by the reciprocal of that. Now I have some common factors that I can cancel out. I have an x plus 3, and that's going to leave me with 2 over x squared. And the last example here has several things I can factor, so my first rational expression, y minus 3 over y, what's that going to be, minus 2 times y minus 8, okay, times, and then let's multiply by the reciprocal, y minus 8 over y squared minus 9 factors into a y plus 3 times a y minus 3. And now I can cancel out common factors. So I'm seeing a y minus 8, and I'm seeing a y minus 3. And again, I have nothing left on top, but there is actually a 1 up there over y minus 2 times y plus 3. And again, you could multiply that out and have a trinomial in the denominator, or you can leave it in factored fashion like that. So I have a couple practice problems I'd like you to try. So there's one multiplication and one division here, so go ahead and stop the video and do these in your math journal. Okay, let's take a look at these two problems. So for the first one, I need to multiply these two rational expressions, and I'm going to factor them first. So this factors into y minus 4 times y plus 1 over 2 times y plus 5 times y plus 5 over, and then here I can take out a common factor of y minus 4. Now that I have both of my rational expressions completely factored, now I can cancel out common factors, and I'm seeing a y minus 4, and I'm seeing a y plus 5, and this y cannot cancel with this y because this y is not being multiplied by the 1, it's being added to the 1. So that's going to leave me with a y plus 1 on top over 2y. And let's take a look at our last example here, last practice problem here. I will factor the numerator, so that's going to give me n plus 3 times n plus 4 over 16n squared times, and then I'm going to multiply by the reciprocal, 2n over n plus 3, and there was nothing to cancel there. So nothing to factor there. So now I can cancel out some common factors, n plus 3, and then 2 goes into 16 8 times, and then the n is going to cancel with one of these, so I'm left with n plus 4 over 8n. So in this video we took a look at how to multiply and divide rational expressions, which is very similar to multiplying and dividing fractions. Multiplying straight across the top, straight across the bottom, dividing, multiplying by the reciprocal of the second one. The one thing you do need to do first, before you can do any canceling out of common factors, is make sure that you have factored each expression completely.